Okay, here are some guidelines for implicit differentiation. I didn't go over these before I did the other ones because this is going to involve you having an equation, whereas the examples that I just finished were just expressions that you were asked to do the implicit differentiation with. All right, so since we're dealing with equations, first step says differentiate both sides with respect to x. So, you're dealing with an equation, so you'll have the left side, you'll have the right side. So, doing what I had just explained on the previous examples is what you will do to each side of your equation. Okay, then step 2 says to collect all terms involving dy dx on the left side and all other terms on the right side. Now, of course, you can actually reverse that if you would prefer. I mean, you can put all the terms containing dy dx on the right and everything else on the left. But in other words, all terms involving dy dx need to be on one side by themselves. Okay, so if you have all terms on one side involving dy dx, then that would allow you to do step 3, which would be to factor out dy dx from all of those terms, with the fact that they all have that in common. And then step 4 would be to solve for dy dx. Okay, so this will be the process that we're fixing to go through with the following examples. All right, so find dy dx by implicit differentiation. Okay, so as I said, you'll have a left side and a right side. So starting on your left-hand side, of course, you have sums and differences here. So you are allowed, remember, to take the derivative of each of those terms individually. All right, so starting with the first term, using your power rule, you would have 3 times y to 1 less power. But since this is a term containing y, but yet you're asked to do it with respect to x, remember, this is where you would have to include the dy dx. Okay, second term would be the same situation. This is a term containing y. Using your power rule, you would have 2 times y. Of course, to 1 less power would drop that to the first power, dy dx, minus the derivative of 5y would just be 5, but then you'd have dy dx, because each of these terms contains only y, so that's why each of these would have dy dx. Now the last term is a term only containing x, so using your power rule, then you would have 2x. And then on the right hand side, the derivative of a constant, remember, is just 0. Okay, so there's step 1. Step 2 was to get all of the terms containing dy dx on one side, everything else on the other. So if I leave these 3 terms on this side, and then this term I'm going to shift over here, of course I would end up adding 2x on this side. Okay, now I'm going to kind of do 2 things at once. I'm going to go ahead and shift this over, which means I'm left with these 3 terms all on the left-hand side. So if you remember, the next step was to factor out dy dx. So I want to pull dy dx from each of those terms. Of course, this is just like greatest common factor. So that would leave me with 3y squared plus 2y minus 5. Okay, so basically I did step 2 and step 3 there together. So step 4 is to solve for dy dx. So in other words, I want dy dx on one side by itself. That would require that I divide both sides by the set of parentheses. So that would leave me with dy dx is equal to 2x divided by 3y squared plus 2y minus 5. So that would be your answer. Okay, number 2. Okay, following the same steps. Okay, find the derivative implicitly for each side. So the derivative of sine, remember, is cosine. So this would be cosine y. But since this involves y, remember, then you'd have to multiply by dy dx. Of course, that is the only term that you have on this side. So now differentiate your right-hand side. The derivative of x would just be 1. Okay, so now, actually I don't have to worry about step 2 because this is the only thing that contains dy dx. It's on the left side. This doesn't contain dy dx, and it's already on the right side, so you're ready. You think about the next step. The next step was to factor out dy dx from all of your terms, but again, you don't do that because there's only one term here to begin with. So you're ready for step 4, which is to get dy dx by itself. So that would require that you have to divide by cosine y. So you would have dy dx is equal to 1 divided by cosine y. So that would be the answer for that one. Okay, next. Okay. Taking the derivative of the left-hand side. Of course, the 3 here, is just treated as a constant multiple. So taking the derivative here, this would need to start off with your power rule because you'd have to do 2 times your function to 1 less power, and then we'll start with chain rule and take the derivative of the inside. All right, so the 3 is a constant multiple. So going with my power rule, I would have 2 times the function to 1 less power. So that would just drop down to the first power. Then you have to take the derivative of the inside. Well, this is a sum, so you're allowed to take the derivative of each of these terms individually. So the derivative of x squared would be 2x plus the derivative of y squared would be 2y dy dx. Because see, that is a term that involves y, therefore you would have to do the dy dx. Okay, equals. Now on the other side, again, the 100 could just be treated as a constant multiple, but when you take the derivative of the xy, that's going to require product rule. Okay, so first function, derivative of second, so the derivative of y would be 1 dy dx plus second function times the derivative of the first function. Okay, so let's just kind of get things arranged a little bit better here before we start trying to, get dy dx on one side by itself. Okay, first of all, this of course would just be 6, so I'd have 6 times x squared plus y squared times 2x plus 2y dy dx. You could go ahead and distribute the 100 here if you chose, so I could say that I have 100x dy dx plus 100y. Okay, let's see. So now we need to get all of our terms containing dy dx on one side. What I would probably suggest, let's see, there's a couple different ways you could do it. We're going to need to take some steps and get this multiplied out. Let me just go ahead and leave the 6. We'll worry about that in a minute. Alright, so I'm going to FOIL this out. Okay, so starting with x squared, I would have x squared times 2x, so that's going to give me 2x cubed. Then x squared times 2y dy dx. So that would just be 2x squared y dy dx. Now y squared times 2x. And y squared times 2y dy dx would give me 2y cubed dy dx. Okay, let's go ahead and distribute the 6. Let's just get everything multiplied out and just go from there. Okay. Now that we've gotten rid of all of our parentheses, brackets, let's start talking about rearranging our terms here. Now remember, we want everything containing dy dx on one side and everything else on the other. So I'm going to leave both of these on the left, so I'm just going to bring those down as they are. And let's go ahead and move this over, so that would be minus. Okay, so this is going to stay on the right-hand side, the 100y. And then each of these terms would need to be subtracted. Okay. So now, let's see. Of course, they've got the dy dx in common. They also all have a 4 in common. And I'm going to go ahead and take that 4 out as well, because I can take a 4 over here and I'll be able to do some canceling there. So if I take out a 4 dy dx, so I will have 3x squared y plus 3y cubed minus 25x. And let's go ahead and take the 4 out here as well. Okay, so now in order